let's try some examples of expressions involving exponents. So let's start pretty basic. If we have x to the fourth and we raise it to the negative fifth power, we have something raised to a power raised to another power. So remember, that means that we can multiply our powers. So we actually get x to the negative 20th. And remember that when you have a negative exponent, that just means we bring it down to the bottom of the fraction, or make it 1 over x to the 20th. Not so bad, right? So this one, we have y to the negative third over y to the seventh. There are a couple different ways we can do this. So first of all, we can just remember the rule that if we have y to some power over y to another power, we can just subtract their powers. Be really careful about signs. So we end up with y to the negative 3 minus 7 power, or y to the negative 10. Another thing we could do, so as I said, multiple different ways, is we could recognize that y to the negative third is 1 over y to the third, which would bring it down to the bottom of the fraction. So now we have 1 over y to the third times y to the seventh. When we're multiplying two things with different exponents in the same base, we can add them. So we get 1 over y to the 10th, which is exactly what we got here. Y to the negative 10th and 1 over y to the 10th are the same. So for simple examples, there's usually just one or two ways to do that. It's not a real big deal that there are multiple ways. However, once we get into more complicated examples, there's going to be many, many, many different ways to do them. So just be careful, pay attention to what you're doing, and you should be okay as long as you follow all the rules. Let's look at this example. Let's just deal with the numerator first. We have xy raised to the third power. That means I have x times y times x times y times x times y. But I can group those x's and those y's, so that's the same thing as taking x to the third times y to the third. Then on the bottom, I have all of these things raised to the 1/2 power. So that means I'm going to take 3 to the 1/2 power, x to the negative 1 to the 1/2 power, and y squared to the 1/2 power. So there's nothing more I can do in my numerator. X to the third, y to the third. The denominator, I'm going to leave 3 to the 1/2 as 3 to the 1/2. It's the square root of 3. It's not a number we know off the top of our head. Then I have x to the negative 1 to the 1/2, so I multiply those, so I get x to the negative 1/2. Then I have y squared to the 1/2. I multiply those and just get y. So now the last thing I want to do is I want to make sure I don't have repeats of x and y. So I have x to the third over x to the 1/2. It's going to be x to the 3 minus 1/2. The 3 to the 1/2 is going to stay on the bottom. And then I have y to the third over y. So y to the 3 minus 1. Well, 3 minus 1/2 is going to be 5/2, so x to the 5/2 y squared over 3 to the 1/2. So there we go. That one, there wasn't as much flexibility on what we were going to do next, because we had to distribute these through before we could actually start simplifying. Let's look at this one. Now, there are a couple different ways you could do this one also. I can either distribute my negative 1 power across the top, just like I did in these two examples, so that 3 to the negative first, x to the third to the negative first, y to the negative first to the negative first, or I can bring that whole term down. So let's do it with distributing the power first. So we have 3 to the negative 1, x to the negative 1 times 3, so x to the negative third, y to the negative 1 times negative 1, or just y to the first. Then the bottom is all set, except that I have a square root of y in there, and the square root of y isn't going to help me with exponent rules unless I write it as an exponent. So I get my exponent of 1/2. So the 3 to the negative 1 is 1 over 3. So the 3 is going to come down to the bottom. The x to the negative 3 is also going to come down to the bottom as x cubed, and then the y's are going to stay where they are. And so is the 4. So we get 3 times 4 is 12. X squared times x cubed is x to the 5th, because I can add those powers. And then I have y on the top and y to the 1/2 on the bottom. I subtract those powers. I get y to the 1/2 over 12 x to the 5th. So now just as an illustration, again, there are a couple different ways you even could have gone once you were in here already. If I did this the other way, so instead of bringing the power through, I brought that whole thing down to the bottom first. I'd get 1 over 4x squared, square root of y, which I'm going to write as y to the 1/2, times 3x cubed y to the negative 1. So now I can start multiplying on the bottom. I have 4 and 3. It's going to give me a 12. I have x squared times x cubed. I add those to get x to the 5th. And then I have y to the 1/2 times y to the negative 1. So y 1/2 plus negative 1 will give me y to the negative 1/2. But if I have a negative exponent on the bottom, it means I have a 1 over y to the 1/2 here, which means it's going to pop back up into the top. And I'll get exactly the same thing. So this is just an example of how you can do this many different ways and still get the same answer. Okay. So there's no promise I can do these every way you could choose, but let's try at least a couple different ways with this one. So first of all, notice that I have a 3, a power of 3 for all of these terms, and a power of 2 for all of these terms. And then I have a power of negative 1 for the whole thing. So again, I have two main ways that I could start this. First of all, I could get rid of these two powers, bring them through. So I can take 2 to the 3rd times y to the 6th to the 3rd, or sorry, x to the 6th to the 3rd, so x to the 18th, times y to the 2nd to the 3rd, so y to the 6th, times z to the negative 1 to the 3rd, so z to the negative 3rd. On the bottom, I have x to the negative 3, so x to the negative 6th when I raise that to the 2nd power, y to the 7th squared, so y to the 14th, and then I have z, the square root of z squared, or z to the 1/2 squared. That's just going to be z to the 1st. And then this whole thing has a negative 1 power. But that means that I'm taking the top, the numerator, to the negative 1st power, and also the denominator to the negative 1st power. But notice these powers are the same, so I have two options again as to where I want to go. I can either start simplifying this expression first, or I can distribute these negative 1s across. So I think I'm going to go back to the way I had it, and I'm going to simplify inside the parentheses first. So, I just have a 2 to the 3rd, that's just going to be an 8. That's going to stay on the top. I have an x to the 18 over x to the negative 6. So that's x to the 18 minus negative 6, so I get x to the 18 plus 6. I have y to the 6th minus y to the 14th. And then I have z to the negative 3rd minus 1. So that's what's left. So let's actually simplify that. So I have 8, and then I have x to the 18 plus 6 would give me 24. 6 minus 14 would give me y to the negative 8. And then I get z to the negative 4 to the negative 1. Now, again, I have options here. I could either bring these down to the bottom now, or I can distribute the negative 1 first. Let's distribute the negative 1 first. So I have 8 to the negative 1. I have x to the 24 times negative 1, so negative 24. Y to the negative 8 times negative 1, so positive 8. And z to the negative 4 times negative 1, so z to the positive 4. So let's bring what we can down to the bottom. So I have 8, and it becomes just 8, and x to the positive 24, and then on top I have y to the 8th, z to the 4th. So we'll go back to this one. I'm using up all my space over here right now. So now, let's try this a different way. What if I had said, well, I need to take a negative 1 power of the top and a negative 1 power of the bottom. Then I have 2x to the 6, y squared, z to the negative 1, raised to the 3rd, then again to the negative 1. On the bottom, I get x to the negative 3, y to the 7th, square root of z squared, then to the negative 1. Well, we're raising something to the 3rd power and then to the negative 1 power, so we can multiply these. So we get the whole top piece raised to the negative 3 power, and then we get the whole bottom piece raised to the negative 2 power. And I'm going to write that z as 1/2. The square root of z is z to the 1/2. So now, I'm just in a situation where I have 2 powers and I need to bring them across. So I get 2 to the negative 3, and then x to the 6 times negative 3, so negative 18, y to the 2 times negative 3, so y to the negative 6, z to the negative 1 to the negative 3, so z to the positive 3. And then I get x to the negative 3 times negative 2, so x to the positive 6. Y to the 7 times negative 2, so y to the negative 14. And then z to the 1/2 to the negative 2, so z to the 1st. Negative 1st. And now we can just simplify. So this, the 2 to the negative 3rd, which is 2 to the 8, which is 1 over 8, comes down to the bottom. Then I have an x, the negative 18 minus 6. I have a y to the negative 6 minus 14, and then a z to the 3 minus negative 1, so plus 1. So what we get, coming back over here, is we get 8, and then negative 18 minus 6 is going to be negative 24, so I'll bring that down as x to the 24th. Minus 6 minus 14, this should be minus negative 14, so plus 14, gives us a y to the 8th on top, and then we get a z to the 4th on top. So, you see we get exactly the same thing either way. And I still didn't even cover all the different ways you could have done that. There are still a couple more that you could have done in either way, or you could have even started by just flipping it. So, there's a lot of different ways you could have done this. As long as you get this answer in the end and you're following all the rules carefully, you should have been fine. You should have a valid way to do it. So let's move this example over here, since I took over all the space. So 3x to the negative 7 times the square root of y times z to the 5th to the negative 1 over and the whole thing squared. Okay, so we'll do a couple different examples of how we could work this one. Again, I probably won't even cover them all, but just double check that you're using your rules carefully and you should be okay. So my first thing I could do is I could take these powers that are on the inside and deal with them each individually. So I have the -1, so I get 3 to the -1. Then I have x to the -7 times -1, so I get +7. I'm going to write the y as y to the 1/2 instead of the square root of y. So I get y to the -1/2 when I multiply by -1. And then I get z to the -5. Then I get x to the 5 times 4, or x to the 20th. Then y to the -3 times 4, -12. Then z to the -1/2 times 4 will give me z to the -2. And then I can't forget that the whole thing is then squared. Now, I chose to simplify within the expression over here. You could do the exact same thing. You could start simplifying the x's, the y's, and the z's as we go, but I'm going to actually distribute that too. I know that I'm squaring the top and squaring the bottom. That's just how it works when we square a fraction. So I'm going to do it this way this time. So I have 3 to the -1 times 2, -2, x to the 7 times 2, y to the -1/2 times 2, so that's -1, z to the -5 times 2, over x to the 40th, y to the -24th, is -12 times 2, and z to the -4th. So I've gotten rid of all my outside powers now. All I have to do now is just simplify everything and move the negatives so they're no longer negative. So 3 to the -2 means that I'm taking 3 squared and putting it on the bottom. Then I have x to the 14 minus 40, because I have x to the 14th over x to the 40th. I have y to the -1 minus -24. And then I have z to the -10 minus -4. Well, x to the 14 minus 40 is 40th power is going to be x to the -26th power. Y is going to give me y to the 23rd power, and z is going to be to the -6th power, still all over 9. So I want to bring my negatives to the bottom. I get y to the 23rd over 9 times x to the 26th, z to the 6th. Now, let's follow this convention. Let's actually square both of these exponents before we do anything else. So this is one way, this is another. So I'm going to take the whole numerator to the -1, then squared. So I can multiply these two powers. So I get 3x to the -7, y to the 1/2, because I'm going to rewrite that, z to the 5th to the -2. On the bottom I'll get x to the 5th, y to the -3rd, z to the -1/2, and then that's all going to be to the 8th, because I have the whole denominator raised to the 4th squared, so I multiply to get 8. Now I can just deal with these powers, so I get, let's see, 3 to the -2, x to the -7 times -2, so -14, y to the 1/2 times -2 to the -1, z to the 5 times -2, so -10. Then on the bottom I get x to the 40th, y to the -8 times to the 8 times -3, so -24, and then z to the -1/2 times 8, which is 4. And if you notice, this is What did I miss? Oh, so notice this is a -7 and a -2, so I should get a +14. This and this are the same. Notice I had to catch that mistake by checking them. So we do the same thing. So let's take 3 squared and bring it to the bottom. Except I can rewrite that as 9. And then another way we can think of this is I have x to the 14th over x to the 40th. So the bigger of the two is on the bottom. So what's left over when I subtract these two is going to go on the bottom. So if you feel more comfortable writing it all out this way, it's a much surer way to do it. It's going to give you the right answer every time. If you try and figure it out in your head, sometimes signs get messed up. You end up putting things in the wrong place. So just be slow, be careful, be methodical. But if you feel comfortable with immediately going from here to here, like I'm doing here, that's fine. So this y to the 24th is going to move to the top. The y to the 1st is going to move to the bottom. So I'll have y to the 24th over y. So it's going to cancel one of them. So I get y to the 23rd. And then the z to the -10th will go to the bottom. The z to the -4th will go to the top. So I have z to the 4th over z to the 10th. The difference is 6, and that goes on the bottom. So we get the same answer either way. Just takes a lot of careful attention to signs and addition, subtraction, what goes where.